Good day. Today we will tell about the elements of symmetry of crystalline structure. You remember the elements of symmetry of crystals, but there is a difference between the elements of symmetry of crystal and the elements of symmetry of crystalline structure. And so you will see that. Then we will study the simple element of symmetry crystalline structure translation, and the next element, the Glasing reflection plane. In the beginning of our lecture, I want to remember you the elements of symmetry of crystal. They are the plane of symmetry, the center of symmetry, simple axis of symmetry. I hope you remember that only the axis, the first, no, of course, it's obviously the second, third, fourth, and sixth order of symmetry are possible in the real crystal. The next element of symmetry of crystal inversion axis of symmetry. The order of inversion axis are the same as the simple axis. These are the second, third, fourth, and sixth order of symmetry. Here you can see the elements of symmetry of crystalline structure. Some elements of symmetry for crystalline structure are the same as the elements of symmetry of crystal. These are the plane of symmetry, the axis, simple and screw of symmetry, but not inversion, but screw. We will tell about that later. The translation, the new elements, helical axis of symmetry, the new element, and Glasing reflection plane. On this slide, you can see the definition. What is it, the translation? Translation is an infinitely repeated transfer, parallel of course, to a certain distance, called the translation period. It should be distinguished clearly. Translation is the symmetric transformation, and translation the element of symmetry or translational period, or at the edge of the unit cell. A translation is the simplest element symmetry for the crystalline structure. The combination of a translation with planes and axis of symmetry gives two more elements of symmetry. So the next element, Glasing reflection plane. A reflection plane is a set of jointly acting symmetry planes and parallel translation. In this case, the transfer is made by an amount equal to half the translation period. The action of the Glasing reflection plane can be demonstrated using the chessboard. Look at this slide, please. In order to combine white square 1 with square 2, similar to it, you have to move square 1 to the place of the black square above it, and only then to reflect this plane in the plane B perpendicular to the plane of the drawing. With such a joint transfer, not only will square 1 coincide with square 2, but square 2 with square 3, and so on. Similar Glasing reflection planes with sliding components are derived too, pass along the A line. The same sliding reflection planes can be found in a flat grid on the sodium chloride structure. You can see here. where sodium is a black circle, it will be combined with another sodium ion if it is reflected in the plane of gliding reflection B and transferred along the plane by B derived 2. With this transformation, sodium ions and chloride ions, light circles, are symmetrically combined with each other. The sliding reflection planes are conditionally represented as dashed or dotted lines. You can see here. And denoted by the symbols A, B, C when the gliding is directed along the X, Y, Z axis respectively, and its value is A derived 2, B derived 2, C derived 2. The gliding reflection planes are of the type N, clinoplane, that can be detected in the BCC lattice. I hope you remember what is it, the BCC lattice. And according to the classification of Bravais lattice, it is the body center lattice. D type diamond that are characterized only for FCC lattice. I hope you understand that the acting of the gliding reflection plane, it is a combination of the reflection and the translation, and the joint acting create the new elements symmetry of crystal structure. It is a sliding reflection plane or gliding reflection plane, another name. Next lecture we will introduce with the other elements of symmetry. They are the skew symmetry axis. Thank you. The symbols. The sliding reflection planes are conventionally represented as dashed or not dashed lines and are denoted by the symbols A, B, C when the ellipse is directed along the X, Y, Z axis. I want to repeat this definition, that it is necessary to remember that.